Welcome to ReneEnergy.com on YouTube, the hub for all things renewable energy and sustainability. Imagine a chain, strong and reliable, yet its weakest link can bring down an entire $100 million facility. In the world of green hydrogen, that link might be hiding inside a valve. It's tiny, often overlooked, but when it fails, the consequences are monumental. This is the reality faced by project developers, EPC firms, and plant operators every single day. A leaking valve doesn't just mean lost hydrogen, it means lost money, momentum, and potentially lives. It's a risk that can't be ignored. Today, we're uncovering the dark horse of hydrogen infrastructure, valves. These aren't just plumbing hardware, they're critical components that must contain the world's lightest element, the most flammable gas, and pressures up to 13,000 pounds per square inch. Hydrogen is the smallest molecule in the universe, highly reactive, flammable, and difficult to contain. These traits make it a promising energy carrier, but they also make it a nightmare for mechanical systems, especially valves. A standard valve that works just fine in an oil refinery might fail catastrophically in a hydrogen electrolyzer or fueling station. Hydrogen can generate seals, cause material embrittlement, and degrade gaskets and elastomers over time. This is why specialized hydrogen valves are essential. Hydrogen valves aren't just off the shelf. They're precision engineered to survive high pressures up to 13,000 bar, wide temperature ranges from cryogenic to high heat, and intense chemical interactions with the most reactive element. Imagine a 100 megawatt green hydrogen plant running at full capacity, producing thousands of kilograms of hydrogen daily. A leak here isn't just a minor inconvenience, it's a hidden cost that can have significant financial and operational impacts. Picture a microscopic leak in one high-pressure valve. Over a year, that leak could release tons of hydrogen, costing millions of dollars in lost revenue and increasing safety risks. It's a microscopic catastrophe with massive consequences. Hydrogen is invisible. You can't see it, smell it, or detect it easily. A leak might go unnoticed for weeks unless you have the right sensors and detection protocols in place. In 2022, a leading European hydrogen refueling station halted operations due to valve seat failure, costing over $2.5 million in downtime, repairs, and penalties. Here's another truth: stainless steel is not always safe for hydrogen. Surprised? You're not alone. While 316-liter stainless steel is widely used, hydrogen can cause embrittlement in certain grades, making material selection crucial. Hydrogen embrittlement weakens metal at the atomic level, increasing the risk of sudden fracture. Preferred materials include monool for high nickel content, Inconel for high temperature resistance, Hastelloy for superior corrosion resistance, and nickel alloys for proven hydrogen compatibility. Then there's the issue of seals. PTFE, Vitin, and other elastomers used in typical valves may degrade or leak when exposed to hydrogen. But these advanced materials come at a steep cost, a ticking time bomb many developers are tempted to avoid. Hydrogen valves must comply with rigorous standards, but here's the problem: there's no unified global standard that covers all use cases. This makes it difficult for buyers to distinguish between marketing fluff and engineering reality. Key standards include ISO 19880-3 for gaseous hydrogen fueling stations, ASME B31.12 for hydrogen piping and pipelines, and EC 79/2009 EU regulation for hydrogen vehicles. Manufacturers must test their products against these standards, providing certificates, test reports, and leakage data. Some resellers rebrand or relabel valves that were never meant for hydrogen. Without independent verification, developers may unknowingly install non-compliant hardware into multi-million-dollar systems, posing significant risks. Common valve failures include seat leakage, stem blowout, seal degradation, thermal cycling stress fractures, and hydrogen embrittlement. Each failure carries risk, not just financial, but human. It's crucial to understand these failure modes to prevent catastrophic outcomes. Why do developers cut corners on critical safety components? The economic pressure behind the problem is immense. With a target LCO of $2.00/kg, developers face capital cuts, leading to cheap valves, HR-rated value penalties, and the million-dollar mistake of $1 saved equating to $100,000 in failures. Many green hydrogen projects race to achieve LCO of $2/kg or less. Developers are under pressure to cut CapEx, and valves are an easy target. This cost-cutting leads to buying non-certified valves, omitting leak detection systems, and skipping preventive maintenance, all of which are how million-dollar mistakes are made. Every dollar saved on a cheap valve today could cost you $100,000 tomorrow. Essential actions include using only hydrogen-tested valves, demanding full documentation, designing for failure scenarios, implementing preventive maintenance, and partnering with hydrogen experts. Don't let valve failures derail your hydrogen projects. The technology exists, the standards are available, and the expertise is out there. Your next steps include auditing your current valve specifications, verifying supplier certifications, implementing detection systems, and training your team on hydrogen-specific requirements. Thanks for tuning into the ReneEnergy.com YouTube channel. We trust you found this episode and